This is episode 6 of Project 250, my attempt to build the first ever 250 mph RC car, pushing on from the success of the Beast last season. And with just 2 weeks before its first test, it still looks like this. In this episode, I finish the entire build, reveal the final name and livery, and take the car to ROSSA for its very first test. And honestly, I have no idea what's about to happen. ROSSA Round 1 was only 2 weeks away, but there was one problem. I didn't have the final aluminium parts. So I started assembling the car using temporary 3D printed parts, just so I could get the wiring sorted. But then, my delivery from PCBWay had arrived. If these parts hadn't arrived on time, I wouldn't have had a chance of running the car at ROSSA Round 1. As usual, the parts were really well packed and the quality from PCBWay is always incredible. These are all CNC machined aluminium parts, apart from a steel wheel drilling guide and a new flywheel for motor testing. Getting parts made through PCBWay is actually really simple. You upload your CAD, choose your process, material and finish and get an instant quote. Then, a few days later, your design becomes real. Now I could finally build this thing properly. MakerBase kindly provided the 84100 VESCs I needed for the build. First task was swapping the cases for the special mounting plates. That went smoothly. Mostly. Oh my god, that was funny. What we're going to see here is plenty of thermal compound between the lower plate, which has got all the fats on, and the heatsink. You get a good conduction of heat away from the fats and to the heatsink there and to the air. And also you can see there's a bit of a shiny coating over it all, which I believe is some sort of conformal waterproof coating. Next, I used a new toy to crimp on some connector tubes, ready to receive the motor wires. It took a while to get these plates ready, but will they fit into the chassis as I wanted? Got that little recess that I mentioned on my 3D print video, so that goes right up there and then the servo just slides in. The black guards are there to guide the wires over the front suspension and servo and to give some protection against debris off the wheels. The rear end build was pretty similar to the front, but without steering. I was loving how shiny the PCBWay parts were and how easily they went together. about to start soldering, and this is actually a very tricky job. So I've got to join these two wires from the front speed controllers together, join them onto that wire there, which is then going to go all the way to the back of the car and then join onto the rear speed controller wires. And then I've also got to have some connection to plug the power from the batteries onto that main wire there. And I've got a bit of a cunning plan for that. On my previous car I soldered a connector with a bit of 6-gauge wire, but I realised I could actually just solder the connector directly on, which is what I've tried to do here on this mock-up, and it's actually gone quite well. So I think that's what I'm going to do, because it actually cuts out a bit of wire and cuts out another solder joint, so it's got to be a good thing, right? It's 8:20 AM on Sunday morning. In 2 weeks' time, it'll be day 3 of ROSSA Round 1, which kind of focuses the mind a bit. You can see here I've got something that looks like a car now, which is great, but there's still quite a bit of wiring to be done. I've got the main power harness in, but it needs the CAN network installing that allows all the speed controls to talk to one another and get the signal from the receiver. Last night I installed these components. So I've got the receiver there, the VESC Express, which is the data logging unit in a little 3D printed mount I knocked up, perfect pass gyro, and the auxiliary battery. And there's plenty of space for speed measuring devices like the race box. Yep, so CAN harness is the order of the day, and then sensing for the motors. I need position sensors on the rear motors and temperature sensors on all 4. And then I think I'll be done. I've finished the CAN harness, you can see it here. Goes under there, through that little hole there, around down to the back of the car, and then across to the other 2 speed controllers and the logger. And I've got to say, I think I've done a reasonably neat job with that. It's going to be tied down, obviously, so it doesn't flap around, but I'm going to make sure it actually works first. And a good way of doing that is to check the resistance across the 2 CAN channels. The resistance should measure 60 ohms, but 80 ohms. Well, more is better, so 80 ohms. Why would it be 80 ohms? Don't know. A bit of messing around with some tiny resistors later, and 60.2, so perfect. Next task on the list is to add sensors. I've got thermistors for temperature of each motor and position sensors for 2 of the motors. These little PCBs detect a magnet in the back of the motor and tell the VESC what position they're in, helping the car to pull away smoothly, after which they don't really do anything. Eventually, it was time. First power up. I started off with the receiver. There we go, we've got steering. And the perfect pass gyro operation was looking super smooth. Next, the speed controllers. I am quite nervous. I shouldn't be, because it should be fine, but I'm still a bit nervous. I was starting with 12S, which is at the lower end of the voltage that I'm going to run this car on. So when I connect this, it'll power up all 4 speed controllers. So I'm just going to do it gently to start with, in case I need to disconnect it hurriedly. Right, here we go. It shouldn't spark. Yeah, I can see 4 lights on the speed controllers. That's great. Look, I've got 2 lights there. Even the lights on the position sensors are on. And at the front, 2 lights as well. Next was time for motor detection. And hopefully you don't see any smoke, because that has happened before. Right, here we go. Be ready to unplug. It's looking good, it's looking good. That is so cool. That's why I wanted to do this now. So I've done the input setup, so now it should run, theoretically. The fronts are twitching a bit because they can't start turning on their own. Whereas the rears, because they've got the position sensors, they've got no issues. Oh, that sounds fantastic. I gave the front motors a nudge to get them turning. There we go, got all 4 running, yes. Now onto wheels. I had 5 car sets to true down to size. Thank goodness for the OP tyre truer I made last season. It was smoky work. To fit the wheels I had to drill extra holes using this drilling guide. With the holes drilled, the wheels bolted up with precision. I could finally put my machine on its wheels. What's the ground clearance looking like? It's looking like it's pretty much as planned, about 10mm on the front and about 15 on the rear. At the end of the last episode, the aerodynamics were finally sorted, but the actual body, it still needed a lot of work. The shell was printed in 5 separate sections. These were glued together first, then reinforced with fiberglass on the inside. And honestly, at this point it looked terrible. Even after sanding, the joints looked bad and there were layer lines everywhere. And at 250 miles per hour, smooth matters. So began the least glamorous part of the project. Filling, sanding, more filling, more sanding. Eventually though, it started coming together. So satisfying. But after primer, there was even more sanding. This was getting tedious. But eventually, the filling and sanding paid off. And after paint, this thing was looking ridiculously smooth. Last episode, I asked you guys to help name the car. There were loads of great suggestions, but one name got the most votes by far. Mach Reaper. I love the name because Llanbedr, where the car's going to run, is near the Mach Loop in Wales, where fighter pilots go to practice their low-level skills. And this thing is hopefully going to reach speeds that could be measured in Mach numbers. Plus, the whole project originally started with a drone. So Reaper felt fitting. With the final details added, it was honestly looking even better than I'd imagined when this project started. I was slightly worried when I looked underneath and saw how close the front wheels were to the body, but once I turned the steering, it became clear the CAD had been right all along. There was an optimised amount of clearance. Satisfying. It was the same story inside the body. There was just enough space for the Onyx 6S 6975 packs. Optimised clearances means optimised aerodynamics. And because the Mach Reaper is going to roll out soon, I wanted to make something to commemorate it. So I designed this Mach Reaper launch hoodie. I think it might be my favourite design yet. If you want one, links below. The car looked finished, but before I could take it to ROSSA, it needed a VESC setup that wouldn't cut out when the RPM went high, something that was almost guaranteed to happen with the default settings. So I broke out the motor dyno once again, along with the new flywheel from PCBWay, and started trying to dial it in. After about 30 runs and some challenges, I settled for a slight change from the settings I used for the Beast, but honestly, I had no idea of how confident I could be in it. I updated the settings on the car and packed everything away, without ever actually driving it. The Mach Reaper looked incredible, but would it actually live up to expectations once it hit the runway? I was about to find out. Here we are back at Llanbedr Airfield once again. It's the day before ROSSA Round 1 and who knows what's going to happen this weekend. But I think one thing's certain, and that's that it's going to be epic. Welcome to ROSSA Round 1 2026. We're back at the runway at Llanbedr, ready to hopefully set some new PBs. And I'm going to be seeing what the Mach Reaper can do. The line where records are made. We're getting a toilet delivered, that's going to be handy. And then there's a few fewer gazebos than usual. Rory's there on the stand, and then we're looking down towards the traps. And there's the lovely flags and the windsock there. Just got a bit of wind in it. Well, not horrific wind, but there's significant wind. Got a pit set up ready now. Rory's new massive chair. My jacket chucked on the floor. Yeah, there we go. There's the Mach Reaper. Batteries are on charge. Rory's got his car ready to run, the Banzai custom chassis, and there's his Habao, which we're probably going to run tomorrow. There's the body for the Banzai. Just recording this so I don't forget, but I've just noticed there's actually some quite nasty bumps on this part of the runway, like in line with this. So that is pretty much where I was running last year. So I'm thinking I need to run a bit more over this way this time. So probably over towards that line there. But I mean, there's probably bumps on this line somewhere else. So I'm going to have a bit of a walk around, have a look. This is another option for the line, staying tight into the white line. But there's not much margin for error because the white line itself is actually pretty rough. So I am still thinking it might be better to go more down about here, sort of between where that sort of lighter band is and the middle. Yeah, I think that's probably the one to go for. Nice, but I mean there's obstacles like this everywhere. Quite lumpy bits of banding where they've tried to repair cracks in it. The day started well when I was presented with my 225 miles per hour cap from last season, complete with my custom colours, design and name on it. A really cool moment, but it was time to get back to business. Once I'd helped Rory get up and running with his heavily modified FTX Banzai, check out his channel if you want to see more on that, it was finally time to prepare the Mach Reaper for its first ever run. Here it is, ready to go out for its trimming run. Pretty exciting.
Armed.
Right, here we go then. Let's hope this thing works. Steering trimming went smoothly, which was a great sign. Well, that is running lovely. I can't. Oh my God! Look at that there. Beautiful hairy caterpillar. Then it was time to send it through the traps. All right, first run of it then. I decided to start quite near the tower so I could properly see what the car looked like under full acceleration. Run one of the Mach Reaper. Yep. Oh, I forgot to turn my lights on. Cheers. And based on the simulations, I thought it should do about 180 miles per hour with a 300 metre run up. All clear, yeah. And honestly, the run looked solid, but there was a wiggle. The car self-corrected almost immediately, but it was definitely enough to get my attention. At 250 miles per hour, something like that could end very badly. Then came the speed.
Thank you. 180.
Yeah! Awesome.
180!
Yes. Exactly 180 miles per hour through the traps. And 182.35 miles per hour on GPS. That was a really good sign. The car's performing almost exactly as predicted. After that promising run, all looked good on the car, apart from a weird discharge from the motors. Looks like some oil's leaked out of the motors, and then dust and that has stuck to it, like there. It was on there, but I wiped it off, and a bit on there as well. Do not know what that's all about. Interesting. For the next run, I swapped to a fresh set of BSR purples and increased the run up to about 500 metres. There she goes. Good to go then.
Trap.
214 miles an hour.
Thank you.
Nice one.
Cheers. This time the speed jumped massively. 214.41 miles per hour through the traps and 217.45 on GPS. Pretty amazing for the car's second run. The wiggle seemed to have turned into a veer this time, but it was controllable and I didn't feel worried about this yet. Oh, my legs are shaking a bit. Well, there we have it, straight after the run. Bit of dust on the inside, look at it, all in here. No tyre debris because the tyres are fine. The blustery conditions were predicted to be better for day 2, so I decided to leave pushing further till then and help Rory the rest of the day. Back at the Airbnb that evening, I started digging through the data logs. At first things looked really promising. The Mach Reaper was behaving almost exactly as expected, but only up to about 200 miles per hour. And after that, the acceleration started tailing off badly. Then I found the problem. Massive current instability in the VESCs. My heart sank, because I knew that this wasn't going to be an easy fix in the field. Not without being able to do repeated dyno testing. So the Mach Reaper was off to a seriously promising start. It only took 2 runs to get well over 200 miles per hour. But could I solve the instability issues on day 2 and push even further? Tune in next Friday to find out. Trust me, you have to see this one. And make sure you're subscribed. Don't forget to check out PCBWay and my new merch. See you next time.
Deploy the shoe.
Oi,